Welcome back and thank you for joining me. Today we're still on the same section on 6-2, but we're going to focus on division. Okay, so yesterday we covered multiplication. Now we're going to be dealing with the division side of radicals. Now, the first step that I would always take, you want to make your life easier. So if the fraction itself reduces, even if the radicals are written separately, if both things are inside of a radical, you can just reduce them like a normal fraction. So what I mean by that is, here, 2 divided by 18. Well, 2 divided by 18 is the same thing as 1 over 9. All right? So you want to reduce that. Write it just like that. X to the 5th divided by x cubed. Well, remember that when you're dividing radicals, you subtract, or when you're dividing, you subtract exponents. 5 minus 3 is 2, so you're left with an x squared. So the first thing you always want to do is simplify, okay? Reduce the fraction. Now you can say, well, square root of x squared. Well, 2 goes into 2 once, so I get an x. Square root of 9 is 3. And that's how you get your answer. But it'd be a ton harder if you don't simplify first, all right? So let's talk about this next one. 162 divided by 3 is 54. Y to the 5 divided by y squared. 5 minus 2 leaves me 3. Now this time, 54 is not a nice perfect cube. So I do need to come over to my list here. I'm dealing with a third power. And remember, 54 divided by 27 is 2. So this one I do have a little bit more effort into simplifying, but it's honestly still not that bad, okay? It'd be a whole lot worse if I didn't simplify first. Cubed root of 27 is 3, with the 2 stuck inside. 3 goes into 3 once, so my y pulls out, and there's my simplified answer. All right, how about the next one? 50 divided by 2 leaves me 25. X squared divided by x to the 6, 2 minus 6 is a negative 4. And remember, what that negative means is you can just put it on the bottom, and that takes care of the negative. 9 minus 1 leaves me 8. Square root of 25 is nice and easy. It gives you 5. Square root of y to the 8, 2 goes into 8 4 times, and 2 goes into 4 twice. And so you get that when you reduce it, or when you take the radical of it. So this kind of division isn't all that bad. Sometimes it works out really nicely for you, okay? The thing to always remember, though, is you always want to reduce the fraction first before you even consider dealing with the radical. Now, sometimes, though, even when you reduce it, sometimes you're going to have to rationalize the denominator. Okay, now you've seen this before. We dealt with this back with imaginary numbers in chapter 4. So you are aware of rationalizing the denominator. It's a little bit different when you're dealing with exponents, though, with radicals. So let's take a look at some examples. And again, these steps, if you pay attention to my words and follow along, you're going to catch all of those steps. When you're doing your independent work, if you need to reflect on what I'm doing and why, then you can follow along right there. So the first thing is you'll always reduce if you can. Well, in that first example, there's nothing you can do to reduce it, so I'm not even going to bother. Now, what you need to do is look at the bottom, okay? whatever piece is inside the radical still, you need to take that piece and you need to complete it. Now, by complete it, what I mean is here to complete it, I need 4 of them. Right now, I have just 1 3. So how many more do I need to complete that root? Well, I need 3 more. So I need 3 to the third more of them. Okay, but I can't just multiply the bottom by that. You need to multiply top and bottom by that. Remember, that's the key, so I'm not changing the value of what we're looking at. So again, to complete it, I need 4 total. If I'm starting with 1, that means I need 3 more. Okay, now 3 cubed is just the number 27. Okay, so on top, when I multiply those, 2 times 27 leaves me with 54. Now, on the bottom, look at what you were trying to complete. So here, I completed the number 3. Okay, so that means that is what's going to be left over after I simplify the radical piece, because it's what was completed within the radical. So all that's going to be left when that smoke clears is that 3 that was down there. Okay, so this can get a little bit messy, so I left us numerous examples to work through to make sure we feel confident. But again, the goal is just completing what is in the bottom. So let's take a look at this next one. The first thing I notice, 14 divided by 10. That can actually reduce. Both are divisible by 2. So this actually can reduce to a 7x. And this can reduce to a 5y squared. So again, first step, always just reduce what's there. Make it easier on yourself so you have smaller numbers that you're dealing with. And now, even after we simplified, we have some nastiness in the denominator. We can't have radicals in the denominator, so let's take a look at getting rid of them. So I need to complete the root for both of them. This time I'm dealing with a third root, so I need to make sure I ultimately have 3 of each piece down there. The 5, right now I only have 1 5. So to complete it, I'm going to need 2 more. So I need 5 squared. The y squared, well there I already have 2 of them, okay? It's already squared. So to complete it, all I need is 1 more sitting down there, and then it'll be fine. But of course I can't just multiply the bottom by it. I want to make sure I'm not changing the value of anything. So I multiply the top and bottom. So on top, 7 times 5 squared, well, 7 times 25 gives me 175. Then I have an x and a y. On the bottom, look for whatever you actually completed. I completed a 5 and I completed a y. So that is what's left in the bottom. Whatever you ended up completing is what's left down there. Okay, and if you do this right, you should be done simplifying. Okay, even if you look at your chart, you'll notice 175 can't be reduced at all. Okay, it can't be broken up. So let's look at our next example. Well, our next one actually doesn't reduce at all. 5/6 doesn't reduce, and then none of the variables do either. So this one I'm actually set to already work on completing what I've got. Okay, so let's take a look. I have a 6 down there. So I have 1 6. To complete it, I need 3 of them. So I'm going to need 6 squared. For y's, I already have 2 of them. I already have a y squared. So to complete it, I only need one more. And then the z, I only have one, so I need two more to complete the z. I need a z squared. And of course, I'm going to multiply top and bottom by that same thing. So let's combine the top. 5 times 6 squared, so 5 times 36 leaves me with 180. And I have x squared y z squared all up there. On the bottom, again, always look for what did you actually complete. I completed a 6, I completed a y, and I completed a z. So those three elements that actually got completed, they break free from the radical and are just sitting down in the denominator now. Okay, that is how I rationalized them. So this piece does take quite a bit of work, okay? It really takes a good understanding of these radicals, but as long as you follow these steps, I know that you guys can manage doing these problems. So here's one where now the variables do start messing with each other. So let's simplify this. So 7 and 2 can't reduce at all. X divided by x squared. So 1 minus 2 leaves me with a -1. The negative means it's going to be sitting down here. Y squared divided by y squared, that actually just cancels off completely. Anything divided by itself just becomes 1. Z to the 4 divided by z squared, 4 minus 2 leaves me with 2 of them up here. All right, so that piece right there was, again, me just reducing my fraction, okay? It was me not wanting to have to deal with extra variables, extra numbers. But now, even when I simplify it like that, even when I reduce my fraction, I still have a radical in the denominator. So this is how I know that it's time to rationalize the denominator, because I still have a piece of it down there. So let's talk about what I'm going to have to multiply by. I need 3 of them. Okay, that's what the 3 means. To be complete, there has to be 3. So that means I need 2 more 2's and 2 more x's. So let's take a look. 7 times 4 is 28. Then x squared, z squared. And then on the bottom, always look for what pieces did I end up completing. I completed a 2 and I completed an x. So on the bottom, that's all that's going to be left. And then it's finished, okay? Everything is simplified and there's no radicals in the denominator. That's the biggest thing. You cannot allow radicals in the denominator. All right. Last example. The following rectangle has a side length of cubed root of 3 and an area of cubed root of 7. What is its width? So in the previous notes, we talked about how area is length times width. So if I'm looking for the width, what that means is the width is the area divided by the length. Okay, algebraic manipulation, we talked about that back in chapter 1. Okay, solving for a different variable. So area divided by length, well, that sure looks like something we just did. That looks like a rationalizing the denominator problem. So let's take a look at how to go about doing that. It doesn't reduce at all, 7/3. There's no common factors in there to reduce it. So I'm just going to jump right into the completion part. So I have a 3 in the denominator. I need to complete that 3. I need 3 of them. So I need 3 squared. All right, so when I look at the top, 7 times 9 leaves me with 63 on top. On the bottom, always look for what did you end up completing. Well, on the bottom, I completed a 3, and so that's what I have left, and now I'm done with my problem. So that's our last example. So once again, now after you're done with the video, I'd like you to write that summary piece for me. Any questions, anything interesting you've learned, any extensions that you think you want to know about, whatever you want to write for the summary, please make sure you do so for me to look at when I check your notes tomorrow and come back ready for your practice work.